With a good understanding of JavaScript objects and their use as data structures within JavaScript, as well as understanding JSON, the JavaScript Object Notation for plain text formatting of data so that it can be easily passed across the internet to and from systems or from a web API to a browser, now it's time to jump into how do we get the JSON from another web server, API, or web service. How do we get that data? And what we're going to run through today is we are going to run through the Xmlhttprequest object. Now for that, I'm going to go ahead and create a new project. So I've got myself a new folder created, and I've got it opened up in Visual Studio Code. I'm going to go ahead and add a new HTML file. I'm just going to call it index.html since it's the first HTML in the file. And we're going to go ahead and add our doc type to it. And then we are going to build our basic HTML structure with our head and title. We'll just call this basic async web requests is what we're going to call it. Then of course we need our HTML body for content to go in, and then I'll just add an H1 and we'll put the exact same text that we have from our title in there, just so when we run the page we know what page we're looking at. Now of course, in order to maintain separation of concerns, we're going to go ahead and add a separate file for our async calls, and just for demo purposes we're going to call this asynchrequests.js so that we know what that file is for. Now we've got our JavaScript for writing the JavaScript. Let's go ahead and tie it to our HTML page. I'm going to go ahead and, as we should with our JavaScripts, we should run them at the bottom of the body so that they run after all of the HTML has been loaded. And that is because normally we're going to be modifying our HTML as a result of what happens inside of our JavaScript. Most of the time that's what's going to happen. And because of that, we want to make sure our JavaScripts are not loaded until after the DOM has been created. So we're going to go ahead and put these down at the bottom of the body. I'm just going to put custom JS for this page, just so I know what's down here. And then let's go ahead and add a script tag with the source set to our async requests.js file. And then we'll go ahead and close that script. And now we should be ready to go. We should be ready to start developing our asynchronous JavaScript calls to the web services that we're going to be using. Now, this video is not about how do we sign up for our API keys and all that kind of stuff at openweathermap.org. This video is about the XML HTTP request, how do we make calls, and how do we parse the data that we get back from that API. So I'm not going to go into that. That we can reserve for in-class sessions or for a different video if it becomes necessary. So don't worry about how you get this URL that I'm going to be using. Just know that we're going to be calling the openAPIweathermap.org, and then I have my private API key right here. So you shouldn't be using it. You'll need to sign up and use your own. So I know you can pause the screen and pull my API key, but I'll probably just change it after this video to be safe. So now what we're going to learn about here is we're going to be learning about the Xmlhttprequest object that is provided to us by the web APIs provided by our browsers. And so inside of our browsers, as a part of JavaScript, we receive what is called the Xmlhttprequest object. And what it does for us is it allows us to make asynchronous calls to other web servers or to our own web server or web APIs or web services. And we can actually pull and get information from those other services. Now, you can easily look up the documentation for the Xmlhttprequest object by going to the developer.mozilla.org, which is the developer the Mozilla Developer Network, and then go ahead and do a search right here for the Xmlhttprequest object. And you can read all about it. You can see what kind of functions it has, what its methods are, what kind of events it kicks out. And you can see some code samples on how to use it. So we're going to start off with the basic code sample right here. And we are going to demonstrate how we might load information from a web server that comes to us in the form of JSON. And the reason why we picked the Open Weather Map API is because the data is returned to us from that API in JSON format by default. All right, so first things first, I like to wrap any of my HTTP requests that I'm going to be sending out. I like to make sure that those are wrapped in their own functions that I can call when I need that data. And since we're going to be calling the, well, let's not call the forecast, let's just call the weather for today's weather. So we're just going to call the weather API. And so since we're calling the weather API, I'm going to go ahead and create a function that's just for that. So let's do function, and then we're going to do call weather API. And just so I know, we're going to make sure we know that it is an asynchronous call. So I'm going to do API, and I'm just going to put async after it. And then this function doesn't need to take in any parameters because we're going to have the URL that is specific to this weather API right here inside of our function. Now again, don't be confused by this API URL. If you want to follow along, go to openweathermap.org, so just this URL right here. Sign up for an account and then get yourself your API key. And then go look at the weather API, and you should be able to put together your own URL with your own API key, and you should be able to go ahead and copy what I'm doing in this video, and it'll help you figure out how to make an API call to that openweathermap.org. All right, so I've got my URL. It's stored inside of this variable right here. That's the URL we are going to be using to make our asynchronous call. Now, the object that we were talking about that allows us to make asynchronous calls to web servers, that is going to be the Xmlhttprequest object. So we're going to need a new instance of that request object. And how we do that is we define a variable, so let xHTTP, and I'm going to say equals new Xmlhttprequest. So that's how we initialize a new Xmlhttprequest object. So what this does is it uses a constructor function, which we haven't learned too much about right now, but it uses a constructor function which knows how to go and build an HTTP request object for us, and then it gives us it back as a reference right here. So we've got our own custom version of an Xmlhttprequest object that we can use to now make a call to this API right here. So we need that object first. And then we need to go ahead and provide a way for this object to process the data it gets back from the web server. Now, this is where things get interesting and where we lose a lot of people when we're learning about asynchronous calls. So let's do a little bit of drawing here, and let's talk about what exactly an asynchronous call is. So asynchronous. And let's say versus synchronous. Let's talk about what the two differences are. Now, in a synchronous process, what happens is, and I'm going to do it over here on this side because that's the side synchronous is on. When we do synchronous, what happens is we have this progression of time. So let's go ahead and note that as time. And time is flowing from top to bottom. And when we are dealing with asynchronous code, or when we're dealing with synchronous code, what happens is we have a statement right here that needs to be executed by our JavaScript runtime. And it sits right here. And in a synchronous code block, what's going to happen is that all statements are going to be executed in the order that they are received by the JavaScript runtime, all right? And they will execute only after the previous statement has been executed and completed. So what that means is that as time is flowing, this object right here, or this statement, is going to be executed, so that block of code is going to be pulled into the JavaScript runtime, and it is going to be executed. And depending upon how much time it takes to run that particular statement, what will happen is it'll start right there, and it'll continue to run until it finishes. Once it finishes, then the next statement can kick off, and it'll run for however long it runs. Maybe it only runs about that long. Then the next statement will get kicked off by the system, and it runs for however long it needs to run. And then the next statement would then get executed. Now, this is synchronous, meaning that this statement right here cannot be executed until this one comes to a complete stop. In other words, it is done doing what it needs to do. Then this one will run, then this one will run. And this one looks like it's long running, so this statement doesn't run until this one is completely completed. All right, that's kind of redundant, but completely completed, I like it. Now, in an asynchronous world, when we're dealing with asynchronous calls, we're going to have time running right here, just as we did over here on the synchronous time. And the time continues to run top to bottom. So we'll go ahead and note that. We'll do the exact same thing. So time is running from top to bottom. And then the difference here is that we might have time running, but we have, instead of one process running, which handles each statement alone, what's going to happen in an asynchronous world is we are going to have the JavaScript runtime, which runs right here. And then we are also going to have the web API runtime, which handles all of our asynchronous calls. And let's go ahead and note those really quick. So we got our JavaScript runtime, and that lives right here. And then, on top of that, we have our web API, which is really the browser. So we'll just do browser runtime right here. And then we'll just note that this is the web API that is provided by the browser to run JavaScript. All right? So now here's what happens. We are still going to have some synchronous statements that have to be executed. So we'll have this statement right here, and it's waiting to be called. And then we'll have another statement that needs to be executed, and it can only execute after that statement has completed because this is still synchronous. So let's note that really quick so we can keep that in mind. The JS runtime is synchronous. Okay? It can only run one statement at a time, and it runs those statements until they have completed. All right? Now the browser runtime over here, it handles all of our asynchronous stuff. So it is asynchronous, and it sits right here. So we've got these statements right here. If we look at our code, so let's jump back to our code really quick here. We have synchronous code happening, like this particular statement right here that generates the variable that holds our API URL. It has to come to completion before it can create this new Xmlhttprequest object. All right? So these have to happen, and they have to complete before the next one does. So all of this code is synchronous in its functionality. So if we run back to our diagram right here, it would be the same as this is that variable that holds our API URL, and then this one creates our Xmlhttprequest object. So why don't we go ahead and let's rewrite this so that we know exactly what's happening in the code that we're writing. And this should help us out. And so we called it our URL and our XHTTP request objects. So let's go ahead and do that. So we've got our URL, So that's the variable that's being built by that statement. So I'm going to put a semicolon after it so we know that it's a statement. Now, that's a pretty lightweight statement, so we know that that one's not going to take very long to run. So let's just say it takes about that long to run. Then we're going to have the creation of our Xmlhttp object, which that's the name of our variable, but it's really an Xmlhttprequest object being created with this statement. So let's go ahead and use our Xmlhttp to represent this statement being executed inside of our code. And what we're going to do is we're going to continue to update this diagram as we write our code. So let's go ahead and add our Xmlhttp object, Xmlhttp, and we know it's a statement, so it's that entire line of code. Now it's going to execute after the URL statement has finished executing, and maybe it takes just a little bit longer because we're actually building a full-blown object and allocating memory and stuff like that. And so right now we're dealing 100% with synchronous code, or code that runs synchronously. All right. Now we're going to jump into more synchronous code, but synchronous code that sets up our asynchronous call that is going to be handled over here by the browser's runtime. So let's do that really quick. So we have our Xmlhttprequest object, which we've called Xmlhttp. And now using that object, this is where we are going to set up an event handler. Now in previous videos, in the previous module, we learned about handlers and event handlers, or listeners, right? Where we could set up a listener and provide a handler for that event. Now Xmlhttp, because we are making calls to a web server, we don't know how long it's going to take for that call to happen. So what we're going to do is the Xmlhttprequest object provides us with some events that we can set up event listeners for and provide handlers to. And we do that through the Xmlhttp, and then I'm going to use the onReadyStateChange event. Now, when we do an event, we have to provide for it a handler. And so on this event, I'm going to go ahead and provide the handler that is going to be executed when this event gets kicked off. And as we know from our events and handlers and listeners videos, the handler is really just a function. And that function is usually anonymous, meaning it doesn't have a name to it because it gets assigned to this variable. And so when the onReadyStateChange event happens, the Xmlhttprequest object is going to go to this particular variable and it's going to call whatever handler we provided. And in this case, we're providing a function that it can execute. And that function is where we are going to provide the code that handles getting back all the information from the web server, from this openweathermap.org API, when we get that response back. Now, this is where all async code happens. Well, all code that processes the return of the async process. All right, and we'll make that a little bit more clear here in a minute. So let's go ahead and let's talk about what happens after we've provided the handler, and then we'll go back and we'll write the handler. So right here we've added our handler, so let's go ahead and do that. So onReadyStateChange, this is synchronous code. So this has to execute before this can execute. This has to execute, in other words, setting up the handler, because we're not actually calling this handler, right? We're providing a function definition to be stored here that can be called when the onReadyStateChange event takes place. So this code all has to execute before this next code, and we have here the Xmlhttprequest object, and then we are going to go ahead and open up the request, and we are going to send a GET request. So remember, HTTP, the HTTP protocol that we learned about way early on, it provides the functions or the methods that we can ask a web server to do for us. And get, like anytime we open up a browser and we make a request for a URL, such as we're going to Google's homepage or something like that, it's always a GET request because we are getting information. Then we provide the URL, and of course we defined our URL variable right here, so I'm just providing that right there. And then we want to go ahead and just handle that. All right, so that's the open, and then we have our XHTTP request, and then we want to go ahead and send the request. So that's another block of code. All right, so let's go back to our diagram and let's follow how this is all happening. So synchronous code, synchronous code, synchronous code, keeping in mind that the function isn't being executed. We're creating the definition and we're storing it here for later. It's not being run. Then we are opening up our request and providing the URL that we want to call, and then we are actually making the call. So let's go ahead and add these to our diagram. So we've got our onReady state change, our open, and our send. Let's add those to our diagram. All right, so the next one that we have is going to be our onReady state change. We don't want all of that in there, and we know it's a statement, so we know it's attached to that XHTTP object, so I'm going to add it right here. And let's say that this one, because we're setting up stuff, we're adding a function, it has to allocate memory and stuff, it takes a little while to execute too. It has to execute to completion before we can move on to the next code. And the next code is our XHTTP, and it was the .open function that we were calling. And that sets up our Xmlhttp request to be sent asynchronously. Oops, we accidentally deleted that, so let's add it back. XHTTP.open, semicolon. All right. So that one, it might take just a little bit because all we're doing is providing some variables. And then we had the actual send, where the XHTTP object was actually sending our request over the internet and setting up the async stuff. So here we go. All right, and so it takes a second to run because really all we're doing is saying, hey, go do it, right? Now, we gotta note some stuff here. When we call the http.onReadyStateChange, what is happening here, now keep in mind, I'm at a super high level, so there's a lot more that goes behind the scenes, but we want to have a basic high level understanding of what happens. This XHTTP request object, this is all synchronous code running, but this object kind of lives over here. And when we did the onReadyStateChange, what happened is this handler got pushed over here into our browser runtime. And the browser runtime, what it does is it sets up a listener. Because remember when we talked about events, listeners, and handlers, the listeners for events actually run over here in the browser's runtime, not on the JavaScript runtime. They're running over here. So let's go ahead and mark down that a listener was set up. So XHTTP, and we're doing the onReadyStateChange, and it's a listener that's getting set up. And so that happens over here. And so this listener is set up and it begins to run on this when we click send. So here it's set up, and then right about here when we click send, this is when the listener starts, well, this is when the XHTTP actually executes. So let's do XHTTP, let's say executes. And it's right here, right as soon as the send gets called, that's when the XHTTP executes. So let's go ahead and, I keep doing that, I keep accidentally deleting them. XHTTP, and we'll do executes. We'll drag that over here, make sure I click off of it so we don't lose it. All right. So the listener is set up and it's listening for the onReadyStateChange event to happen. When we say execute, what really happens is we're executing this particular HTTP request, and what it's going to do is out here in the ether somewhere is the Open Weather Map API. So let's go ahead and put that down. It's the Open Weather API. And it's out here somewhere on the internet. When we hit execute, what happens is the Xmlhttprequest object over here outside of our JavaScript runtime, so it doesn't interfere with anything, it is actually making a call to the weather API over HTTP. So let's go ahead and note that. So it's an HTTP GET request, and it's making that call for us. So it does this request, and then what it does is it passes back this request object to the Open API. It passes this request object to our onReadyStateChange listener. And so it's going to sit there and listen on this object for when the Open Weather API passes information back. So let's say Open Weather API, if we're following time, remember time is coming down here. Let's say that the Open Weather API, it takes some time to pull up all of its data that it needs and then prepares that data. So let's go ahead and note that. Prepares data, and let's kind of condense that a little bit. There we go. Prepares data, takes a bunch of time. Once it's done preparing its data, it's going to send that information back. So it's going to send that information back to the caller. And what's going to happen is right here, we're going to have the event get fired. So when this data comes back, the request object, so let's go ahead and note that really quick. We've got our xHTTP.onReadyStateChange. So this event just happens. Event. And that is because this event happens down here somewhere. We'll put it on this timeline. And it happens when we get back the data from this weather API. So this xHTTP object gets back the data, and then that onReadyStateChange event fires. This event, of course, triggers this onReadyStateChange event handler to go ahead and execute. So this guy gets executed right there. So it's going to call this. So right after this, we're going to go ahead and we're going to see this onReadyStateChange listener that we have. It's going to go ahead and execute. So let's add it down here. xHTTP. And this is the onReadyStateChange. And this is the handler, the one that we provided in our code. Handler, and it executes. So we'll go ahead and put that right here. And time is, of course, going down. So here we can see that the onReadyStateChange happened, and then the handler gets executed over here. Well, the handler gets put onto our event queue, if you remember that from our description about events and stuff. So really what happens is that this handler gets called and gets executed right over here. So let's go ahead and make sure we mark that down so we know that the handler is getting executed. So handler executed right here. All right. So hopefully that's not too super confusing. Of course, it's high level, and I'm leaving a bunch of stuff out that is like the nitty-gritty details. But hopefully you're getting how this works. And this line right here might be a tiny bit confusing. So let's go ahead and get rid of it. That way we're not confusing the situation here. All right, that fixes that. Okay, so now this handler gets executed. But if we have other code in our JavaScript file, as soon as this xhttp.send happens and everything gets passed over here to the JavaScript runtime, we're actually going to see that other code, so other script statements, are going to be executed one right after another, right after this HTTP request goes. And so we're just going to see that a whole bunch of other stuff happens before this ever returns, because this could take some time to happen before the handler gets put back on the stack and gets executed. So what that means is that all of this stuff is happening asynchronously. Well, all of the event handling is happening asynchronously. And so other statements and stuff are going to execute right after this. If this were synchronous, what we would see is we would see each of these statements executing, and then the handler would execute immediately after these others. But the handler is tied to an event, and the events all get handled by the browser runtime, and they just kind of sit over here and monitor these requests that we have going on. And it's not until we get something back from the request that the event is fired. And when the event is fired, the handler that we were provided by the developer's code is then put back into the handling queue, and then that queue, once the stack is empty, actually chucks the handler back on there, and then it gets executed at some time later. So events and event handling and asynchronous programming is all about handling events when we don't know how long something's going to take to happen. And in this situation, we're trying to get data back from a web server. So let's jump back to our code really quick. So synchronous code, setting up the listener and everything that's going to happen on the browser's runtime while all the rest of this stuff gets executed. And we've got our other statements that all get executed synchronously, and really, that's the end of the code that we need in order to set up all of this stuff that we saw inside of our diagram. That's it. All of this stuff is taken care of behind the scenes by JavaScript Runtime and by the browser's API. If you don't understand how events happen, make sure you go back and you read or rewatch the video on the event loop and how JavaScript works in the browser. That video is super important to understanding what I just did here and how we laid out how this actual event is set up and how the code executes. Make sure you understand that. All right, so now once we click send, the event handler and everything is set up. We wait for stuff to be returned. The rest of our script gets executed, which means everything keeps running while we're waiting on this stuff to happen. And it's not until we get the data back that the handler, which is this function right here, actually gets called. And so what we need to do now is we need to write some code in here that will help us handle getting the data back from the web server or from this API right here. So we're going to write a little bit of code. This video has already been taking quite a bit of time, so we're going to be quick about this just so we can get the basics. Because this is the onReadyState change event of the Xmlhttprequest object, we're going to go ahead and check to make sure that the ready state is equal to 4. And that is because 4 indicates that our Xmlhttprequest object is ready to go. And then we want to check to make sure that the status we got back from the web server is a 200, which means that we got back everything from the web server and it was successful. In other words, there were no errors at the OpenWeatherMap API. Everything worked just fine. Now the reason why I put this in an if statement and the reason why we're checking the ready state and we're checking the status that came back is because if for some reason anything failed, we're going to want to go ahead and provide to our user some kind of a message that says that things didn't work and they might want to try again. For right now, I'm just going to do a console.log. And in that, I'm just going to go ahead and say API request failed. And that just lets me know in the console that I do. But what you're really going to want to do is you're going to want to present a user-friendly error message. in UI, right? That's really what you're going to want to do right there. Now in here, if everything was successful, inside of the if, we're going to want to parse all the data. So we're going to want to pull the response body and parse it for use in our UI. Now, I'm not going to give you all the code to update your UI. You should be able to go back and look at the videos on how to get references to HTML elements and how to update them. And a good way to do that is to make sure that you get a reference to all of your HTML elements that you want to update. You're going to want to go ahead and watch those videos and figure out where you're going to put those references and then how you're going to update it. For right now, I'm just going to go ahead and show you that the data we get back from the web server is initially just in plain text, and that we're going to need to parse that in order to turn it into JSON. But we want to verify that it really is JSON. So let's do this.response text. And when we do that, and then we run this program, and we pull up our request here, we see that nothing happened. Absolutely nothing has happened in our debugger. We see no console.logs or anything. Let's put a console log before our function. And let's say before API call. And we know this is an asynchronous API call, so let's do before async, just so we know it's an async call. And then we're going to want to do the same thing after the async call. And let's put after, just so we know the order of how things are happening. And then right here, before we click send, let's do another console.log. And let's say sending async request. All right, so this will actually show in the output how things get executed. And hopefully we'll see, based on that, when things get executed and the fact that everything in our script should execute before we ever get anything back from the API. Even though all of our code to handle that API sits right here, it's really being passed over here, waiting until the event comes back, then it gets put back into queue, and then it gets executed once this is empty, which means all of our console.logs should all take place, except for the ones that are inside of our handler. All those console.logs should all spit out before we get back stuff from our call. All right. And we're going to show that as well, because what I'm going to do right here is we're going to put in a console.log, and we are going to do setting up API URL. And so that'll show us when that takes place. And then we're going to do another output just so we can see setting up Xmlhttprequest Object. And we'll get to see that that one executes before all of this stuff happens. And then we're going to do the sending async. So we'll be able to see that this happens and this happens. And let's go ahead and put this after our send. That way we know what happens after these two execute. And so really what we should see is we should see this one first. So that should be logged to our console first. Then, oh, we totally forgot. The whole point of this was that we were seeing that nothing happened here. And that is because we never called our function. We never invoked it. So let's go ahead and let's do the call to it right here. And let's do, what did we call it? We called it call weather API. So call weather API sync. We're going to execute it right there. And boom. So with this order, we should see this one print to the screen first. Then we should see this one second. We should see this one third. And then we should see this one fourth. And if you're confused, you're going to see in a minute, this one should execute fifth. Then we should see this one right here. This one should happen sixth. even though if we look at our code and if we thought about it synchronously, we should actually see this one 4th, this one 5th, and this one 6th. But the reality is this code does not get executed synchronously, right? This code that's inside of our handler, this handler right here, this all executes after everything else is already executed because we're waiting on it to happen later on. So let's go ahead, now that we've got a call to it, let's go ahead and see what happens when we execute our code. All right, we get an error on Xmlhttprequest is not defined. Now to explain this one, what you need to understand is that the Xmlhttprequest object, it is not something that is provided by Node, which is what we've been executing code against when we run it just in our IDE. It has to be executed in the browser because the Xmlhttprequest object, if we look back at this diagram, it lives in the browser's runtime. It's part of how browsers handle asynchronous stuff and events. So all of our JavaScript code, it has to be run in the browser, and that's why we have our index.html, and that's why we have it tied to this. So we're going to go ahead and run everything inside of a browser. Let me pull that over here so we can all see it, and then let's open up our JavaScript console. All right, let's go ahead and reload the page. Now, let's follow our code really quick and let's see if we were correct in our assumptions. We said that before async API call should be called first, so there it is, that's the first one. We said setting up API URL should be number 2, and it's right there. We said that setting up the Xmlhttprequest object should be 3, there it is. And then we said that send async request should be 4, but we get an API request failed. And then we get our sending request right there. And then after async call, which is right here, then we get another API request failed. And here we get ourselves the actual data that came back from our web API. Now you might be asking, why do we have an API request failed here? And then why do we have 2 right here? Well, if you remember, inside of our onReadyStateChange function, we had an else right here to handle when things fail, and then we repeat this right here. Well, the funny thing is that onReadyStateChange, it handles events that happen in this HTTP object when the status changes in our XHTTPRequest object, meaning that the state of this object can change multiple times before we actually get our response back. So saying that the API failed is incorrect. What we should say is API status changed. And so we probably don't want to present an error to the user. We just want to show API status in UI if we think it's important. Otherwise, we can just log it to our console. So let's see what the status changes are that take place in our API call as it happens. And I'm just going to log this to our console really quick. And then we'll be able to see that these aren't really errors, they're just status changes that are taking place. And again, I accidentally hit F5 to run it locally, and we can't do that. So we need to run it in a browser. Let's open up our JavaScript console. All right, so here we've got a status change, and here we've got our Xmlhttprequest object. Status text is OK. So let's print out our status text and our OK and see what we're getting back on each of those with each of these. So let's go back to our code. And then we're just going to do this dot status and status text, I believe is what it was. Let's jump back really quick. XML/HTTP, ready state, status, ready state changed. There's our function right there. All right, so we're just going to do the status and the status text, just so we know that things are going good. So status changed. And then let's go ahead and add to it this dot status, and then this dot status text. Oh, let's just do the text instead of putting a whole bunch of stuff. And then let's get rid of our object print. And let's go back to our code. Let's rerun it. All right. So we've got our async call setting up Xmlhttprequest, Xml status change. We don't have anything, but we know a status change happened. We've got our send async request. We've got after async API call as number 5. So we've got 1, 2, 3, 4, 5, because we don't count that one because that's just an update on the status. And then we've got our status changed right here to OK twice, and then we get our data back. And we can see that all of our data comes back later on at the very end, and that's because we're waiting on that web server to respond to us. It's asynchronous. Hopefully this is really setting in. I might be harshing on this subject way too much, but it's really important that you understand how all of this works. All right, so this is text. But we just learned about JSON, and that when we have JSON formatted data, when we parse that with JavaScript, we can get full-blown objects that we can manipulate. Right now, this whole thing is just a string. So we can check that by doing a console.log, and we can do a type of, and then do this.response text, and we can see that this is simply a string. See right there? It's telling us that it's a string. It's not an object. All of this has not been parsed. So the way we do that, the way we parse the data so that we can use it in our JavaScript as an object, is we use an awesome object that is provided to us by JavaScript, and that is the JSON object, and then we simply use the parse method on it to pull out the data that has come back to us as text. So we're going to need a variable to store the object, or the root object, that is going to be composed of everything else that came back in our JSON. So let's do let weather data equals JSON.parse. So JSON is the object, parse is the method, and then we're just going to pass it our response text. And then it is going to do the job of parsing all of that. So if we do a console.log and we log our weather data object, and then if we do a console.log and we do a type of, just to see what it is, we should see an object printed in our console, and we should see it saying that it is of type object. So let's go back to our browser, reload. Originally it's a string right here when we do the response text. We parse it, and now we've got a full-blown object. And you can see it follows the text one. We got coordinates. It's made up of an object, which is the Latin long. Oops, let me expand that back out. We got our coordinates with our Latin long. But here you can see that it is an actual JavaScript object now, because we parsed the JavaScript object notation, or the JSON, into a JavaScript object structure that follows the same hierarchy as the JSON text does. But we've got real objects that we can now navigate all of their properties to get stuff, and we see that the type of gives us back an object. And like we learned in the previous video, we can simply navigate any of the properties within this JSON object simply by using the dot notation or the brackets for indexing arrays, as long as we know this structure. So right here, we know that we can get to base simply by doing, let's do a console.log so we can see the output. We can do weather data dot, and we were going after base. So let's do base. And when that gets output, we see stations. So if we go to base, we see stations right there. And then of course, we can index into other objects. We can do clouds all if we wanted to. So let's do clouds, and let's do all. Run that, we see 50, which is the value of clouds all. And we just can continue doing that now that we have actual JavaScript object with all of its related interior properties, which might be values or objects or arrays. Really useful to understand how JSON works, how we can get JSON from another web server, web service, or API, and how we can parse that JSON into usable JavaScript objects and have the simple access of all of the values contained in those objects using the dot notation along with array indexing.